What's up everybody, Chris Alupului here, and in today's video we're going to be hitting an easy Active Directory box called ShadowGate. Now if you wanted to try ShadowGate, ShadowGate is free currently on the HackSmarter community, not to be confused with HackTheBox, TryHackMe, or OffSec, but the HackSmarter community. And for you to follow along with this lab, you're going to have to go to hacksmarter.org, and then here on the hands-on lab is the ShadowGate machine, and it is currently free. So you can go ahead and click into that, and that's going to take you to this page right here. Now, I've already turned it on by clicking the power and start, because it does indicate here that it takes 5 minutes to spin up, but that is running. One thing I did want to mention that might be a little bit confusing to people that haven't been a part of the HackSmarter community is that they need to click here on the left side into the system, and they need to download the VPN configuration file, the same you would with HackTheBox, TryHackMe, or OffSec, right? So you go ahead and download that, and that's going to be the same way you would do with the others. You just use the OpenVPN and you connect to it. And once you can connect to it, then you can actually reach this internal IP address. In this case, let's go ahead and ping it. And there we go. We can actually reach this box. So that's awesome. Oh, it looks like we got a little lag spike, whatever. All right. So with that being said, let's go ahead and take a look at this. As I mentioned before, this is ShadowGate. It is an easy Active Directory box. So here is the objective. And by the way, this is made by Ross Ketty. Thank you, Ross. I really enjoyed this box. It was a fun box to go through. So he provides us an objective, some information, and then we have here in the initial access some open ports. So that is very awesome that that is being provided. That's great because we can take a look at all this while Nmap is running. So now that we actually have all these ports and that we know that they're open, we don't have to do that Nmap-P-flag that scans all 65,000 or so ports. We can go ahead and just be very specific with our Nmap scan and target these ports in general. So let's go ahead and do that. And while that is running, here is the Nmap scan. I'm using the SC flag, SV flag, and then those ports that were provided to us with the IP address and a min rate 5,000. Because the beautiful thing about HackSmarter community is that each individual lab is just for you, and that's really great. And they also have a lot of labs that have multiple machines, so there's not going to be anybody else on that machine but you. And the other thing that I've noticed is that when you do decide to shut down the lab itself, it retains all the information, meaning if you change some credentials or whatever the case is, you uploaded some files on that and the machine goes down, you could go ahead and restart it and take off from where you left off. All right, let's go ahead and run that Nmap scan, and then we'll jump over back to here. And let's take a look at these open ports. If you're new to Active Directory, this might be a little intimidating, might be a lot of information. So I'm going to try my best and go through what all this means. All right, so just from this initial provided scan, this screams to me as a domain controller because Active Directory has a fingerprint port set. And we're noticing Kerberos 88, port 88 for Kerberos, 389 for LDAP, 445 for SMB, and 3268 for the global catalog. And that's all on one host. And that kind of screams the reason why I say that this is a domain controller. Now, port 53 DNS AD heavily relies on service records, and that's how the DC usually runs DNS for the domain. And the other thing I'm noticing is 80 for HTTP, which is probably often an IIS. Now on a DC, this almost always means that ADCS web enrollment is installed, and that's /cert serve. All right, so 88 Kerberos KDC the key distribution center, and that's kind of the auth heart of AD in general. So that's a big indicator. 135, which is the MSRPC, and that's going to be used for everything from WMI to DCOM. That's how clients find dynamic RPC ports. 139.445, the NetBIOS, the SMB. You have file sharing and name pipes. I mean, lots of attacks. You got relay, coerce, share enum, a bunch of those things. 389.636 LDAPs, that's the directory itself. That's the database of users, groups, and containers. And then, like I mentioned, 3260, which is the global catalog. That's the forest-wide LDAP for cross-domain queries. Then we got 3389, which is RDP, that's remote desktop. And then 5985, the WinRM. Think of that as like evil WinRM or enter PS session. And then we got 9389, and that's the AD web services used by like get AD user or the RSAT tools. So before we begin a single attack, the box already is screaming single DC AD environment with AD CS web enrollment exposed. So that's kind of like how I have my mental picture laid out for the rest of engagement. All right, our Nmap finished, and let's go ahead and take a look at it. We're getting a lot more information from this Nmap scan, which is awesome. First thing that jumps out to me is here we go. We're getting the domain. So shadow.gate, and then we're also getting the DCO1 shadow.gate. So that's very cool, and we can scroll down, and it's kind of mimicking that information throughout the whole box. And here's more information for the RTP information, DCO1, ShadowGate, ShadowGate, DCO1, so forth and so on. So let's go ahead and add this to our sudo etc host file. And we're doing this so we can resolve the names to the IP address correctly going forward when we're using any type of tool. In this case, I've already added my IP address for this machine, and then 3 different domains, ShadowGate, DC, and DCO1 with the ShadowGate. So I've saved that, and let's go ahead. And from here, what I like doing from our Nmap scan is whenever I see SMB, I just kind of want to know, what is this? What server is this? Now, I may have seen it on the Nmap scan or may have missed it, but I'm going to go ahead and run our trusty old tool, netexec with SMB flag for just the IP address. And here we go. It is indicating that is a Windows Server 2022 build. All right. And it's also giving us the ShadowGate for the domain and the DCO1, as well as saying it's signing false. And the SMB version 1 is not. So that's very cool. Now, the next thing that I like doing is I'll typically dig more into the SMB, or I'll start working my way from the Nmap scan from the top going down. But let's go ahead and let's see from the top going down in this case, because I kind of want to showcase what things that I have run into but are not actually worth the time. All right, so let's start with 53 DNS. So here we can do a dig for the IP address, and then we'll use the ShadowGate, and we'll do an any plus short, and that's going to give us this information right here. Now, dig is a Linux DNS question tool, and he asks for like every record type at once. And the output we're seeing here is just the IP address for our DC. The other thing we're seeing is an SOA record, which is the start of authority, and that's the hostmaster.shadowgate. And now that's not a real user. By the way, it's just the default Microsoft DNS placeholder for the zone admin email. It's encoded with the dot instead of an @ because zone files. So hostmaster.shadow.gate actually means hostmaster at shadow.gate. Don't Kerberoot it. Every single AD integrated zone in the world has it. All right, let's try the same thing. And this time we'll do the AXFR, and we're trying to do a domain transfer, and that failed. Now, if this works, the DNS server just hands us pretty much every record at once, and in modern AD machines, you'll likely see this is going to be locked down or refused. So we're just going to be moving on. Now we can go ahead and clear the screen and then start pivoting back to SMB shares. So in this case, we're going to do SMB here. We use the U flag for the user, and we're just going to leave it empty to see if it can do a null. And then we're going to also just run it with an empty password here just to see if we can do any of that. Now we're not getting anything from here. Let's go ahead and try doing an RID brute 5000. And it looks like we're just getting an access denied here. As you can see, access denied. The other one I wanted to do is, instead of the RID brute, let's go ahead and see if we have access to the shares. And in this case, we're getting a status access denied for an empty username. Let's go ahead and do anonymous and see if that works. And we're getting a status login failure that time. Let's go ahead and try guest. And we're getting a status account disabled for guest. So we're essentially running into a dead end here. We can't really enumerate users. Anonymous is not working. Guest is not working. No username at all is not working either. So we're running into a dead end now with SMB. Now, the reason why we're trying to do the -- shares is because SMB on DCs almost always expose some shares, like the system volume or the net login. And sometimes admin make custom shares with sensitive stuff in there. So, you know, like backup folders, password lists, GPP, XML files, so forth and so on. But we're getting status access denied for the null sessions and a status account disabled for guests. So that's fine. Most modern AD blocks this by default. We also tried the RID brute because every AD object has an SID, and at the end of every SID is a number called an RID. Now, built-ins are 500 for administrator. That's our goal. 501 for guest, 502 for crew root, and real users start on 1000 and go up. So if the DC lets us translate SIDs to names anonymously, we can walk away with an entire user list. And that's pretty common for these type of challenges. But in this case, we're not getting anything. So the DC is refusing the anonymous DCE RPC bind through netexec. So I guess the next thing we can do is we can try doing an LDAP search. So let's go ahead and try this. We're going to do an LDAP, and we're getting an operations error. So we're not getting anything. It is in order to perform this operation, a successful yada yada, so forth and so on. So again, modern AD locks anonymous LDAP down pretty hard. We're not getting any authentication here. All right, so with LDAP locked down, the next move is to Kerberos username Oracle, and this one's kind of clever. Kerberos has a different error responses for users that don't exist versus users, but you didn't pre-authenticate. So you can throw a word list of usernames at the KDC, watch the responses, and walk away with any confirmed usernames without ever attempting a password. And also no lockouts, which is cool. The next tool is going to be Kerberos. So let's go ahead and actually open up a new window, go into the HackSmarter ShadowGate folder, and here we're going to Kerberos username for the ShadowGate and the DC IP address with the seclist users usernames names.txt files. So we're going to let that run, and that's going to start enumerating some users. And there we go. We actually got a username called Athena at shadow.gate. So that is awesome. Now that we have that information, it's probably very tempting to start taking that username and start trying to brute force it with it. And usually that's how you lock out those accounts. And that's typically not the path to go in challenges like this, unless there's some type of hint or indication that you need to do that. So now that we have a username, let's go ahead and do another pivot into using an in-packet tool. And it's going to be the in-packet get NPU users. And here we go. We have the ShadowGate with Athena user. And we're going to try doing the no pass. And we also have the DCIP address for this machine. And no surprise, we don't require pre-auth set. So we're not getting it. And of course, she'd need that flag for this to work, and she just doesn't have it. Now, I want to show you something that I tried before I had any credentials, because this particular attack, if it had worked, would have ended the box right there with 0 credentials. So it's called Petit Potam. I'm sure some of you have heard of it, but here's the idea that there's a Microsoft RPC protocol called MSEFS RPC, and that's just the encrypting file system over RPC, and it has a function like EFS RPC open file raw that takes a UNC path, and if you call it with a path pointing it at yourself, like my IP address /shared/file or whatever, Windows will dutifully try to open that file, which means it will try to actually authenticate to my fake server, and it'll do so using a machine account, in this case the DC01 for the domain controller, which is awesome. Now combine that with something else like ADCS web enrollment, which is on the HTTP. Remember at the beginning of the Nmap scan, we saw that earlier. HTTP endpoints accept NTLM, and NTLM over HTTP can be relayed. So in theory, the attack chain is something like this. Now, most people reach for the petitpotam.py file. That's the standalone Python script. So let's go ahead and open up a new tab and then go into the HackSmarter ShadowGate. And I've already actually downloaded and moved the petitpotam Python script. So here we go. Here is the petitpotam. Let's run it and see exactly what it gives us. In this case, it's coming back with the status invalid parameter. So we're getting blocked here for this. Now this error essentially lets me know that Microsoft patched the anonymous version of the EFS RPC function on this particular build. And that's like some CV from 2021. I don't remember exactly what number. But this, I feel like, is where most beginners stop and conclude that unauthenticated course is dead, or that they need to start digging into needing credentials. And I'm telling you, that might just be wrong, because with petitpotam, the EFS RPC isn't the only door. It only tests that. And so what we're going to do now is actually pivot to netexec, because netexec has a beautiful module called coerce plus, and that tests every coerce primitive, including petitpotam, printer bug, DFS coerce, shadow coerce, all in one shot. So let's go ahead and try that right now. I'm going to clear this screen, and I'm going to go ahead and run this command anonymously. I'm not going to be using the Athena user. I just want to see what that does anonymously to see if we can actually try this. And it looks like we are getting it vulnerable for the petitpotam. That's very interesting. The other thing we're getting vulnerable for is the printer bug. So that's very cool. And now it's going to attempt to do it. And it looks like it came back with a exploit successful on the printer. Okay, so I'm seeing here the printer change notification. So it looks like we are having, we are able to do this with the printer bug instead of the petitpotam. So that's very interesting. So let's go ahead and actually verify this because we aren't running an NTLM relay. We're just testing it with the NetExec Coerce Plus module, and we're not actually getting back anything. So we need to do that. So let's go ahead, open up a new window. And then from here, we'll go ahead and CD into HackSmarter, so forth and so on. And now we will do the sudo impacket NTML relay X here with the IP address. And remember, we were going back with that ISS mentioned, the cert serve, right? Well, this is the endpoint for that. So we're going to do the SMB2 support for ADCS, and we're using the template domain controller. So let's go ahead and run that. And we're going to enter in our password because we are running this sudo for the NTLM relay, which is typically required. And now we can go back here and run that to verify if that's going to go through. And now we're just waiting for connections to come to us. So let's take a look, and it looks like we are getting back something. So that is very cool. And here we go. We got you got a certificate, an ID 5. And it's writing it to the DC01 shadow and the .pfx file. So certificate successfully written to file. So that was unauthenticated. Very cool, very interesting. I'm not sure if this is the intended route for this box to do it unauthenticated. But let's continue down this line so you can see what this attack vector looks like, and then we'll pivot back to maybe doing more enumeration with a username and seeing if we can get a password and how to go through that attack. All right, since we have done that, let's go ahead and open up a new tab, and then we'll use, never pronounce it right, certify AD, and we're going to authenticate with that PFX file that we just got from here. You can see it right here, right where it saved it. The certificate for the DCIP, and let's go ahead and try that. And there we go. We got the hash right over there. So that did work. Awesome, pretty cool. But let's go ahead and then pivot back and see what the actual route for this box is. This is the moment in every AD pen test where you have to just remember that when one tool fails, you're going to have to try a different tool against the same interface. And the reason why I say that is because NetExec RID brute, trying to get our users that way, failed us. But the problem is NetExec is using the LSA RPC, and that's the local security authority RPC service. But there's another RPC interface for the same purpose, and that is the SAMR, the Security Account Manager Remote. It's a different named pipe and a different bind. Now the DC blocked one, but did it block the other? So let's go ahead and run RPC client. And here is the command. We're actually going to open up a new window, CD in here, and we're going to run this RPC client with the -u flag here. And the -u flag is just a null session. We're essentially saying empty username and empty password as well. And the enum users calls for the SARM enumerate user in domain over the pipe SARM. So here we go. Let's launch that. And we got some more users. Awesome. So it does appear the admin did lock the LSA RPC, but they left open the SAMR. And the most important thing from this is always try both. Now, the other thing I've noticed is the usernames actually do confirm something that I suspected. It is the first initial last name format. So you can kind of see the M Brownlee or the B Brown or the J Trueblood. And we would never have gotten these from a first name list. Now, there's one more trick the RPC client can do that's even better, and that's with the query disp info. So let's go ahead and pull that up, query disp info, and let's run that. And there we go. We're actually getting the account names, right? And we're also getting their first and last name. So that is very cool thing to get information on. So we can go ahead and save all this information and put it in a file so that we can finally go forward. All right, next is AS rep roasting. So just as a quick refresher, AS rep roasting works like this. Normally you have Kerberos auth that requires you to encrypt a timestamp with your password and then include it in your initial request. So that's pre-authentication. Without pre-auth, the KDC just hands you back an encrypted blob, and the AS rep encrypted with the user's password derived key. That means anyone can ask for it. And you take this blob offline and you can throw a word list to it, decrypt it, and then you have the password. So no interaction with the DC after the initial request, which is awesome. So let's go ahead and get back into the in-packet toolset. And we're going to get the in-packet get NPU users. So before that, let's go ahead, open up a new window so we can keep this nice and clean. CD here, and then we'll do here, get in-packet. Now we're going to try first Athena because that was the first user that we actually got. And we're also doing no pass with a format for hashcat so that if we do get back something, we can go ahead and crack that hash. Now you notice here with Athena, we're not actually getting anything. Now let's take a look at Athena, and it looks like we did write her name correctly. It's just all first. But let's take another name like J Trueblood and let's try that. So here we go. Here is another with the J Trueblood, and it comes back with the ticket. And here is that hash for that. So it formatted it in hashcat. So we're going to go ahead and just copy this, and we can nano jtrueblood.txt, and we can throw it in here, save it, and now we can hashcat j. Let's try it like this. I have j trueblood, and there we go. So now it's going to start cracking that password, and then there we go. So it cracked it fairly quickly. You can see here it says cracked. Now, if this is your first time running hashcat and you're trying to look for the password, it is actually right over here. So the password is blood_brothers. So that is the password for J Trueblood. It is Blood Brothers. So very cool. We can go ahead and save that. That is in my clipboard now. We could also go ahead and save the J Trueblood, and we'll copy that selection. That's also my clipboard going forward. So now that we have actual credentials finally for something, let's go ahead and pivot back to netexec. Let's do netexec SMB with J Trueblood and the password blood shares. And it looks like we are getting back something. So let's go ahead and do a shares, and let's see if we are getting shares. And there we go. We are getting shares for this user. So these three are pretty common. But the thing that's standing out here is the cert enroll. So with this user, we are getting the read permission for the Active Directory certification service shares. So that is awesome. That looks like a big hint for us. The other thing we can test is we can go ahead and switch it from SMB to LDAP and see if that works for us as well. In this case, yes, it does. And then I think the other one was, what was it? WinRM. And let's see. And we're not able to get with WinRM. Okay. All right. Next up is to pivoting into Certifies. Since we know we will be tackling certificates now, let's go ahead and I'm going to clear the screen and I'm going to paste this. So we are using Certify AD tool, and we're going to try to do the find. We're using the credentials, the DC IP, and we're also using two flags here, the vulnerable flag and the standard out flag, so that we can see what comes out with that. There we go. Now what we're looking for here is we're looking for as we can see here, we're looking for a way to prevest. So we see here the vulnerabilities. It is the ESC8. Web enrollment is enabled over HTTP. Now, this goes back to the initial web scan, right, for the ISS, which was the cert serve that I was talking about. So it looks like this is the route that we're going to be going for, the web enrollment over the HTTP. And this was what we were using to abuse that printer bug as well. All right, let me actually break this down step by step, because this is the most important attack on this box. And what I've noticed is this stems from three misconfigurations. Number one being the certificate service is on plain HTTP, not HTTPS. That means anybody can talk to it. Number two is the SMB has signing turned off, which means that we can actually hijack the SMB connections. And then number three is our listener is up on port 445, ready to just catch any incoming login. So here's the chain, 8 steps followed the numbered arrows. So step one is where we poke the printer service. That's pretty much where we ran that netexec course plus against the DC with no password. And that's pretty much poking the DC's print spooler and basically tells it, go look up a file at this network path that I'm giving you. And by the way, point it back to us. And that's when step two comes in. That's where the DC actually calls back to us. Now the spooler tries to reach the network path, but Windows says before you can actually grab a file from the server, you need to log in. So the DC logs into our listener using its own machine account, which is just the DC01 with the $sign on the end. Now that's pretty much walking into our trap. Comes step three, where we forward the login. So essentially our listener doesn't actually log into the DC. Instead, it grabs it, login mid-flight, and then forwards it sideways to the certificate service over HTTP. And that's where the cert service sees what looks like the DC asking for, please give me a certificate. Comes into step four, where the cert is actually issued. Now the cert service has no idea that this is a relay. It's perfectly just happy to issue a cert in the DC's name, and it ships it back to us. So what we do is we save it as a .pfx file, and that's basically a digital ID with the DC's signature on it. Step five is where we use the cert to log in as the DC, and we hand that ID pretty much to a tool called Certify. And it walks up the Kerberos service and says, hey, I'm the DC. Here's my cert. Kerberos checks it. The signature says, yep, looks legit. And then gives us a Kerberos login ticket for the DC's account. Now comes step six, where we actually steal the password hash. And now here's the slick part. Inside Kerberos tickets, Microsoft tucks a copy of the account's password hash. Encrypted, yeah, sure, but Certify decrypts it for us. And then now we don't have the cert. We have the actual password hash for the DC's main account. Step 7, where we ask for the Kerberos tickets password. That's where the domain controllers regularly trade password info with each other to stay in sync. So what do? We use the DC's hash to log in as the DC, and then we ask the real DC, hey, fellow DC, ship me the Kerberos tickets password. I just need it for, replication. And the DC has no idea this isn't a real peer DC asking. It just simply complies, which finally leads us to the last step, the Kerberos ticket hashing arriving. And that's where the DC sends us back to Kerberos account's password hash. And that's pretty much game over. With the hash, we can forge a login ticket for any user, including the domain admin, and pretty much the entire force trusts it. So that's the whole attack. So let's go ahead and run it right now. All right, let's go ahead and open up a new window, and then we're going to cd here, clear it, and here we're going to do the sudo NTLM relay, and that's coming up and running. And then we're also going to do this. So we're going to do the netexec SMB with the J Trueblood and the password that we are able to actually manage with the same course plus listener, because I'm really curious to see if the two are coming up. And it looks like we are getting a bunch of other things. Here's vulnerable to DFS, coerce, Pete Patam, MS even. It looks like there's a bunch of different exploits for coercion. And here we go. We're getting a bunch of successes here over HTTP, over SMB. And there we go. We have the DC ShadowGate.pfx. So that's awesome. We got the certificate. We can go ahead and open up a new window and go here, clear it. And now from here, what we can do is use the good old certify. So here we go. We're going to certify AD auth with that .pfx, the DC01, and we're going to do it. And I've already done it from, remember, the coerce, the unauthenticated one. So we're going to say, yes, overwrite that. And here we go. We have that hash. Now, why is this hash so powerful? Well, because DC01 is the domain controller's machine account. So by default, DCs, they have that replicating directory changes rights, and they need them to pretty much sync the directory between each other. And that's exactly the right that DC sync requires. So with this hash, what we can do is we can authenticate as DC01. We can ask any DC to ship us a password hash for any account, including the Kerberos ticket. That's exactly the hash that we need. The Kerberos NT hash is what this challenge lab requires. So let's go ahead and use the in-package secret dump here. And we're essentially doing here, we're using the hash that we were able to get for the DC01, which is right over here. And I just threw that all in there. And we're just doing just a DC user, the Kerberos ticketing user. So we're going to go ahead and do that. And that comes back with the ticket. So here it is, Kerberos ticketing hash and T hash right here. If I can actually highlight it. So we're going to copy that. And then we're going to go back to the lab here. And here we go. That is the answer for this lab. So that is essentially it for this machine. I'm going to complete it. And then the last thing I want to do is I do want to stop this machine.